difference of two squares. A square minus b square is a minus b, a plus b. It's very simple. And difference of two squares, a minus b plus b. Now, like for example, if I have this, like for example, if I have 50, let's say 100. Let us go to a simple one: 21 square minus 11 square. So if you have this one and I want to use the same method, this one will be 21 minus 11, 21 plus 11. 21 minus 11 is 10 times 21 plus, that's 32, which is 320. Or if I don't want to use the difference of two squares, I do 21 square is 441 minus 121. It's 320. Now both are the same thing. The point there is that difference of two squares will help you to factorize something just quickly, as in very fast. And one thing you should know is that there is always a subtraction in between the two squares. So if I should do something like this, like right, factorize, I want to factorize like 16s squared minus 49. Very simple. So what I will do is that 16 is 4 square, s square is x all square, and minus 49 is 7 square. A minus b, a minus b, a minus b, a plus b, a plus b. Easy to factorize, just straightforward. So let's do another one. Let's see. Let me make it a bit difficult. Let's say you have 64x raised to power 4 y raised to power 6, okay, minus 9x raised to power, no, use x there, z raised to power 10. Now if you have this, it's just simple. We're going to factorize this. 64 is 8 square, the perfect square. X raised to power 4 is x squared, and y raised to power 6 is y raised to power 3, all square. So if you square 8 square, you have 64. If you square s square, that's it. If you have s square square, it actually makes s square times s square, which is s raised to power 2 plus 2, s raised to power 4. And if you have y raised to power 3 square, is what y raised to power 3 times y raised to power 3, which is what y raised to power 3 plus 3. That's y raised to power 6. So that I've got. So this 9 is what? 3. Z is what? Z raised to power 5, all square. So this will be easy. Let's jump to answer. So we have 8x squared y cubed minus 3z raised to power 5. 8 is square y 3 plus 3z raised to power 5. Voila! So it's very, very simple. To factorize this, you get all this. Perfect square. Alright, in perfect square, it's very simple. 16 is a perfect square, that's 4 square. Oh, that. Yeah. Okay. So in perfect square, we want to talk about quadratic expressions that are perfect square. Like for example now, you have s square is a perfect square. Huh? S cube is not a perfect square because the 3s are not. But s raised to power 4 is a perfect square, which is the same thing as s square all square. So even numbers, they are perfect square. So there are some algebraic expression and quadratic expression that are perfect square. Now, for example, if you have x plus 5 all square is also a perfect square. This is also a typical example of a perfect square. So you know it's written as x plus 5 and x plus 5. So x times x you have x square, x times 5 you have 5x, 5 times x you have 5x, and 5 times 5 you have what? 25. So this is to round it up as x squared plus 10x plus 25. So how will I know that this is a perfect square? That's the problem. You will quickly identify that this is a perfect square, but how will you know that this also is a perfect square? And it's very, very simple. The coefficient of x, that's 10, you divide it by 2 and you square it. Once you get this answer, then it is a perfect square. You understand what I'm saying? You understand? So like 10 plus 2 equals to 5 square 25. So it always works that way, that if you want to know whether this number is a perfect or this quadratic expression is a perfect square, the coefficient of x divided by 2 and square it. So let's look at an example. You understand? Like which of the following is a perfect square? Which of the following is a perfect square? Okay, so let's see some examples. Number 1, we have x squared plus 16x plus 64. Number 2, x squared plus 8x plus 32. Number 3, x squared minus 6x plus 9. Number 4, 4x squared minus 12x plus 9. Now, I want to quickly look at which of these is a perfect square and the one that is not a perfect square. So what we do is this: the coefficient of x, you divide it by 2. That's 16 divided by 2 is 8. So you square it. 8 squared is what? 64. So if 64, then therefore it is a perfect square. Let's see this one. 32 divided by 2, 8 divided by 2, which is 4. Then we square it, which is equal to 16. This is not a perfect square. So because it's supposed to be 16. So then this one is 6 divided by 2, 3 square, 9. That's minus 6 divided by 2 square, that's minus 3 square, that's positive 9. Minus 3 times minus 3, minus times minus is plus. So this one, we divide it by 2, we have minus 12 over 2 all square, which is minus 6 square, which is 36. But remember, this has a coefficient of 4 here. There is 4 here. 4 times 9 is 36. So this is also a perfect square. This is also a perfect square. So this is also a perfect square. You know, here in this one, there is no coefficient of there's no number. It's just 1. So 1 times whatever is that thing. So it is 4. You have to multiply by 90. So this also is also a perfect square. So it's just as easy as that. So to check if it's like if you're given a question like this, like if you are given a question like this, like find the value of x, find the value of k for which the expression s squared minus 14x plus k is a perfect square. And so for which this expression is a perfect square, you just do minus 14 divided by 2 all square equals to k. That's the answer. So we go in minus 14, that's 7. 7 square is what? 49. So k is 49. So it's very simple like that. Just for the expression for it to be a perfect square, that's it. Let's look at another example quickly. So find the value of k for the expression. Find the value of k for the expression. Let me check another example. 9x squared minus kx plus 49 is a perfect square. Now, this one is a bit difficult. So, not that difficult like that. So, what we need to do, normally we're supposed to do minus k over 2 all square to give us the number. That's this one, we divide by 2, we square it, and we give us the number here. You understand? But there's a problem. There's 9 here. So we do 49 times 9, that's 108, that's 36, 44. Okay, so we find the square root of both sides. You have minus k over 2. The square root of is 21. So plus or minus. So take 2 to multiply, you have minus k is equals to what? Plus or minus 42. So k is what? Minus or plus 42. So it can be, k can be 42 or minus 42. So it's very, very simple. If you just want to make this something a perfect square, that's where you double it with it. Let's do one more. 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 One more. One more. Find value of k for which the expression 2s squared plus 18. Okay. 36x plus k is a perfect square. There's a problem here. 2 is this problem. So what I'm going to do first, 2 is not a perfect square. You know, when we were dealing with all these ones, the number was the perfect square there. But yeah, 2 is not a perfect square. So I'm going to factor 2 out. You understand? Like 4s squared plus 12x plus 9. This is a perfect square because 4 here is a perfect square and 9 here is a perfect square. But the coefficient of s square and constant both of them must be a perfect square. But the problem here is 2 is not a perfect square here. I'm going to factor 2 out. Yeah. So I factor 2 out and I have s squared plus 18x plus k over 2. Because it doesn't have a 2 there. So you have to put over 2 there because 2 times k over 2 will give me k. Very simple. So now I got to deal with s squared plus 18x plus k over 2. I want to deal with this only. Now for this expression to be a perfect square, so what I do is that this 18 I divide it by 2, I square it, it's going to give me k over 2. So 2 in 18, 9. 9 squared is 81. 81 is equals to k over 2. So cross multiply. K is equals to what? 162. So it's a very, very simple something. Just what you just need to do, just for it to be a perfect square, the coefficient divided by 2 square it. So that's it. Alright, we want to just quickly factorize this. Let's factorize this. Let's see how it's going to work. Now, it's no more quadratic anymore. This is cubic. 3. There's a 3 here. There's a 3 here. There's a 3 here. There's a 3 here. So what we need to do, we need to break. I notice that x is common here and 2 can go all through. What should I say factorize this? X is common here and 2 can go all through. So I bring out 2x is common in both the 3 terms. So 2x going 4x cubed is 2s squared plus 2 going 22, 11. S going s squared, x plus 2 going 24, 12. S going. So after we done that, so we factor it out. 2 times 12 is 24. So what will I do? We have 1 times 24, 2 times 12, 3 times 8. 3 plus 8 is 11. We take this. So we take 3 plus 8. So we have 2x squared plus 3x plus 8, 3x plus 8x plus 12. Okay, so after you've done that, you have 2x, x is common, 2x plus 3, and 4 is common, 2x plus 3. So we have 2x plus 3, icing is common in both. It remains x plus 4. Sure. So it's simple like that. It's then you don't have to factorize things like this. Then to